the most conservative industries in terms of technologies applied. Rails, bridges, tunnels, locomotives, and rail cars, though all having gradually changed over time, retained their basic characteristics for years. Later, the signal system and positive train control were introduced. With the development of electronics, safety systems have emerged and locomotive operation has become an easier task. Today, however, is a time when automated systems and amenities are sophisticated enough to shift from locomotive operation to control over general passenger and cargo transportation. AVP Technology is the leading Russian company in the development and implementation of autopilot systems, including distributed power, or DP, trains, fuel economy, energy conservation, event recorders, and most importantly, integrated transportation management systems, which are the result of developing the locomotive portion of services for the Elbrus Sim computer facility. Our company has moved on to the development and supply of complex systems for locomotive traction. If earlier we offered various components and parts for certain important applications, such as autopilot systems or locomotive event recorders, now we offer integrated system solutions for the Russian railway system, as well as the railway systems of the CIS and foreign countries. For example, we are working together with the Alstom company, and we have identified a number of technical solutions for GE locomotives as well. Our complex system solutions include an autopilot system, a driver's information system, resource-efficient systems to record and control the consumption of diesel fuel and electricity, an automated start and stop system for diesel locomotives, an advanced firefighting system, and an early warning ignition system. We consolidated all of these systems into a single unified complex, and to top it all off, as it were, we added a control system, which monitors any service malfunctions during operations. In the event of any such service malfunctions on the part of, shall we say, the locomotive crew, the system will prevent the locomotive from being rendered inoperative. It won't permit the diesel engine to either start or stop, and it can forcibly throttle down to reduce load to prevent the driver from damaging the locomotive. Here, this is the sort of complex it is. We've completed it, it has passed operational testing, and it is ready to be put into operation by the joint stock company Russian Railways. We have done so much in 2 years, and we believe that having already put this particular concept into operation in an electronic device has been a huge accomplishment for us. Modern locomotives are equipped with microprocessor systems to control the traction drive, making it a lot easier to introduce additional systems, expanding the locomotive's functions. These systems include, first of all, one of our most innovative developments, the autopilot system. The autopilot system provides continuous control over the train's operating status while it is in motion, driving the train along a given route over a scheduled time frame in accordance with current railway regulations at the permitted traffic speed, utilizing cabin traffic light signals, and at the same time minimizing energy or fuel consumption. The autopilot system provides continuous control over the operational situation when the train is in motion, adjusting the speed to fit the actual circumstances, reducing the load on the traction equipment, and creating comfortable working conditions for the driver. The autopilot system operates in concert with the event recorder, recording the parameters of motion and the parameters of the autopilot. Over the course of a trip, it measures and records more than 200 parameters of the locomotive's operation and the autopilot system. With the help of the data received, it is possible to quickly assess the technical condition of the locomotive, such as the need for urgent repair at the depot or for planned maintenance. Dmitry Volkovsky, head of the development department of ABP Technology. The quality of our company's products has been proven in operation not only by Russian railways, but by such major industrial companies as Sibur, Gazprom Trans, and Russian Aluminum. These enterprises have equipped their industrial transportation with event recorders that allow for the highly accurate measurement of diesel fuel consumption, recording the parameters of diesel generator units and diesel locomotives in general, as well as monitoring the technical condition of the locomotives. Our automated diesel engine start and stop system is in especially high demand. In 2016, the Severnaya railway lines of Russian railways purchased 58 sets of the system for their diesel locomotives. The system proved to be highly efficient, and in 2017, Russian railways ordered that 99 more locomotives be equipped with the start and stop system, which our specialists successfully installed. The event recorder allows for early detection of technical malfunctions of the diesel generator, making it possible for the locomotive fleet to be maintained in good condition. Also, most importantly, the event recorder monitors a locomotive's fuel consumption with high accuracy in real time. In the past, locomotive crews used to measure the level of diesel fuel manually by using a gauging rod. This method was only used as a rough estimation, because for true accuracy, fuel volume should be measured by weight. The event recorder measures both the volume and weight of the fuel, making it easy to determine an accurate figure and to control fuel consumption. We developed a system which helps to economize diesel fuel by stopping and starting the engine automatically. While a similar system is used in automobile transport, our company is the only manufacturer of such a system for railway transport in Russia. A unique feature of this system allows for stopping and starting the pumping of coolant according to the outside air temperature and those of the heat transfer fluids in the diesel's cooling system. When minimum temperatures are reached, the engine starts up again. This procedure helps to save up to 10 tons of fuel a year for such consumers as Russian railways, as well as private locomotive owners who operate throughout the territory of the Russian Federation. According to the results of 2017, we placed more than 150 units of our system into operation in Russian railways, which have already produced a confirmed fuel savings of up to 5% of the total volume of fuel consumed by the upgraded locomotives. Since 2017, our depot has been using the automatic diesel start and stop system on locomotives. The drivers simply call it the start-stop. It allows you to significantly reduce fuel consumption and rule out the human factor. Our locomotives work in Moscow, a large metropolis. By introducing the start-stop system, we have achieved two goals, as we both economize fuel consumption and significantly reduce the exhaust emissions released into the atmosphere, having a positive impact on the environment as a whole. To switch the self-heating system on, we place the toggle switch in the warm-up mode, and then the system runs voice messages telling us what to do next. Engine off. Switch on the automatic oil pump. Set the reversing handle to the start position. Locomotive heating system ready for operation. Attention, the engine will start in a minute. Pumps are off. The circulation of cooling water has stopped. The introduction of wireless data transmission technology into the locomotive event recorder feature, or the driver information system, ensures that data are received and transmitted through a secure GPRS channel. The locomotive event recorder transmits location data, the parameters and status of the locomotive's components, as well as the volume of fuel or energy consumed. The driver information system shows the same data received through a wireless channel and also provides the schedule for the particular train, the speed limit and train composition data, and transmits feedback to the server regarding the train's progress according to schedule. The system makes online diagnostics of the technical condition of the locomotive possible, reducing its downtime and amount of unscheduled work, and putting an end to the need to keep surplus spare parts on hand for repairs. Earlier, RZD and other companies used to purchase spare parts based on the results of the previous year. Now, they are able to buy what they actually need. We have equipped more than 5,000 locomotives with a system that transmits data on the locomotive's working condition through a wireless channel to the RZD server. The system reports the route, the speed, the locomotive stop locations, the list of work carried out, and the necessity for repairs. For example, if a specific assembly has to be replaced. The system will also warn about any problems with the locomotive's operation. The most technologically complex device developed and installed on a locomotive by AVP technology is the autopilot system. For the correct operation of the autopilot system, you need the following: detailed electronic maps of the traffic routes, including route profiles and plans, the location of track amenities, such as signal lights and stations, and their geographical coordinates. A complete list of the speed limits for each route, both permanent and temporary. The schedule of a particular train on a selected route. The train's composition data, including type of rail cars and their loading parameters for the capacity of the freight train. According to data supplied, the autopilot system builds a speed curve forecast and method of operation permitting movement at this speed. Along the way, the autopilot system monitors the speed of movement, the locomotive's location, the parameters of the traction engine circuits, the braking system, and the parameters of the diesel generator unit on diesel locomotives. Selection of the train's operation in the form of traction or braking force, or the position of the driver controller, or the brake valve, is based upon the speed curve forecast and the results of the locomotive's parameter indicators. These data are also registered into the event recorder. In order to increase network capacity, countries with intensive railway freight traffic use distributed power, or DP, trains. This technology is used on the railways of the USA, Australia, Canada, Russia, Brazil, South Africa, and China. The most familiar system used to operate DP trains is Locotrol by GE. We have developed an innovative DP train autopilot system, the ISA VP-RT. The principal difference from Locotrol is that our system was specifically built as an autopilot system for DP trains. That's why, in addition to synchronous and asynchronous modes of remote control over locomotives, it originally autopiloted a DP train with independent control of each locomotive. The system also permits the use of locomotives with different types of control systems, ranging from those that are relay-operated to those that are fully analogous, as parts of a single train. Like any other DP train control or autopilot system, the ISA VP-RT reduces the longitudinal forces on the train, braking and brake release times, and the energy consumed for traction purposes. If necessary, the autopilot system can be furnished with a function which permits driving DP trains of increased weight and length by distributing power along the length of the train. This means that two or more locomotives equipped with this system can be joined into a single DP train, and the system will allow for control over all the locomotives through unified algorithms. The ISA VP-RT system makes it possible to drive a train using independent traction control, in addition to synchronous and asynchronous traction control, and all types of braking modes. This means that the traction force, or the controller position, are selected on each locomotive separately with an account of the specific route profile, reducing the longitudinal tensions on the train. AVP Technology has installed various systems on more than 10,000 locomotives and motor car units. Over 7,000 of them are autopilot systems. Our company has developed technologies that have no equivalents in the world. That's why the Alstom company purchases our equipment for its locomotives, which they supply to the countries of the CIS, including Kazakhstan and Azerbaijan, where our technologies are put to good use. Thus far, the European nations have no autopilot systems as such. While they are still conducting research in this sphere, we are busy producing and installing actual devices. AVP Technologies' innovations are based on modern microprocessor technologies and specialized computing algorithms for safe and energy-efficient automated train driving. Autopilot systems and event recorders used on railways help to increase the speed of cargo delivery and to reduce transportation costs, the amounts of electricity and diesel fuel consumed by locomotives, as well as the cost of their repair and maintenance. I'd like to take this opportunity to appeal directly to the owners of rolling stock, in particular to those who operate their locomotives on 1,520 mm gauge railway track, the republics of the former Soviet Union, such as Kazakhstan, Uzbekistan, Azerbaijan, Armenia, and Georgia. We can offer you actual working solutions that will help you in two ways: to economize on your fuel and electricity, and to provide you reliable control and improvement of the technical working conditions of your locomotives. You will also be able to determine the locomotive's location and the driver's current actions. And the systems we're ready to demonstrate to you in our offices are already in operation throughout the entire Russian Railways network. By using our technologies, you will actually save from 5 to 15% of your costs.